Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And I'm Bretta. For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@curran.org. We're online at dothemathonline.net and on social media.
Nicely done, Bretta. So where do you attend school?
I attend school at Stockdale Elementary.
And what grade are you in?
I'm in 4th grade.
4th grade. You did that so well, I would have thought you were in 5th or 6th grade. You ready for 5th or 6th grade?
Yeah, sure.
Okay, yeah, why not, right? How's 4th grade going?
Good.
What is, a lot of kids say it's good. What's so good about 4th grade?
I like how our teacher explains everything smoothly and clearly.
Well, that is a bonus now, isn't it? If they can explain it clearly and smoothly both at the same time, because rarely do you get two of them.
Yeah.
All right. So what kinds of things have you been doing in math so far this year?
I've been doing decimals and fractions.
And you like that?
Yeah.
Pretty comfortable with it? Mm-hmm. What other things do you do in school that you really like? And you don't have to say just math, because obviously you do other things than math that I'm sure you like.
Yeah. I like PE and reading.
Okay. And are there certain books you like reading, or you just like reading in general?
I like reading, like maybe science books, or sometimes I like reading books that explain about people's lives,
Okay, so biographies about people you want to learn more about their lives and things like that. Good. Well, good. Is there a person that you've enjoyed reading about a lot? You really like learning about them?
I've enjoyed reading about Michael Jordan.
Oh, okay. And are you a sports fan? You like basketball? And is that why you?
Yeah.
So what do you find fascinating about that book that what have you found out that has been interesting about Michael Jordan?
The Nike program, they made a shoe about Michael Jordan.
Right.
Yeah, and every shoe they sold went to the money to Michael Jordan.
Oh, okay.
Yeah.
So that's a pretty good deal, isn't it?
Yeah.
Maybe they'll have a Bretta shoe sometime in the future, you think?
Yeah.
Could be, right? Never can tell. All right. So I'm glad that 4th grade is going well for you so far.
Okay.
So are you ready to help me out with our social media problem of the day?
Yes, I am.
All right. Let's take a look at it together. It's going to be up on the screen. So what does that say?
It says, what is the missing degree?
Right. And do you have any idea what they're asking for or what's going on with that? Have you done anything with degrees yet or anything yet?
No, we haven't learned that yet.
Oh, this is going to be an excellent problem for you right now. All right. So do you recognize anything up there? Does anything look familiar at all, or can you kind of look at it and figure anything out?
No. Not really.
All right. So have you ever seen the number 45 before?
Yes.
Okay, so there's something familiar. Have you seen lines before?
Yes.
There you go, something familiar. Have you seen arrows before?
Yes.
Look at that, what do you mean? Yeah, I don't know anything about what's going on up there. All right, so have you ever seen problems with X?
No.
And probably not, you're in 4th grade, right? So you're not solving equations and you probably haven't gotten to unknowns yet. The little circle, do you have any idea what that means after the X and after the 45?
No.
That means, go ahead.
Fahrenheit or Celsius?
Degrees, right? It could be Fahrenheit or Celsius is what I think you were thinking about, right? That means degrees, all right? So that's why it's saying, what is the missing degree?
Yeah.
So we have 45 degrees and we have some unknown number of degrees. Now, a straight line is considered to be 180 degrees. If we have a circle, do you have any idea how many degrees are in a circle if you went all the way around it?
No.
360 degrees. Okay?
Yeah.
So that's just something to have in the back of your head for later on, okay? So we have a straight line, and that straight line going horizontally across is 180 degrees. and they have a line at an angle, and that angle is 45 degrees. So that means on the other side it has to be something. So do you have any idea what we might be able to do to figure this out now? If the whole line is 180 and we know part of it is 45, what do you think we need to do to get the other number?
Subtract.
Subtract what?
180 minus 45.
Okay, so that sounds like a pretty good plan, right? 180 minus 45. Why do you think that?
I think maybe subtract it and then find the answer, I think, and then maybe like find half of the answer. Like when you divide 36 divided by 2, you would find,
One half would be 18.
Yeah, 18, and then 18, so you would get two sides of 18.
And they would both equal to 36,
Yes.
right? So you're thinking if we subtract the 45 and we put both of those numbers together, we're going to get the 180.
Yes.
All right, so let's take a look at our options. We have 45 degrees for A, B is 65, C is 90, and D is 135. How do you want to go about this? Can you kind of do this in your head? Or are there ones that you know we can get rid of automatically? Because we need to add something to 45 to get to what?
180.
We need to get to 180. If I took 45 and added 45, would that get me to 180?
No.
How do you know that so fast?
Because when you add 5 plus 5, which equal 10, so you would put the 0 at the bottom, 1 at the top, but that would still equal 90.
Okay, so you could do that in your head.
Yes.
Right, so you know that A is out because that would give us 90. What about B, 65? Remember, we have to get to 180.
I don't think so.
Yeah, you don't think so?
No.
All right, what about C? Think about 90 and 40. What would 9 and 4 be?
13.
Right?
Yeah.
Is that close enough?
No.
Probably not. So 135. So think about, take off the 100 if you want.
Okay.
Just think about 35 and 45. What is 35 and 45? What's 30 and 40?
They're like adding, you mean? 70.
Yeah. And what's 5 and 5?
10.
All right. So what's 70 and 10?
80.
And we have 100 too, don't we?
Yeah.
So what's that?
180.
You did all of this in your head. Let's take a look. So you think 135 is the correct answer?
Yes.
All right. Let's take a look and see if indeed D is the correct answer. Check you out, Hotshot. First problem all done. Right? You did that whole thing in your head. You never even knew what angles were, and now you do.
Yeah.
And you know all about degrees. Feeling pretty good?
Yeah.
Excellent. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, well, I know that yesterday for our Math in the News, we did Happy Birthday. Well, Happy New Year now today. So today we are taking a look at the Happy Lunar New Year. So what is Lunar New Year? So Lunar New Year's Chinese New Year celebrates the start of the traditional lunisolar Chinese calendar. The first day is marked by the first new moon that occurs between January 21st and February 20th. So we're in Chinese New Year now. So 12 animals of the Chinese zodiac, and we can see that there are a variety of animals up here. And just as a reference, we wanted to check on Bretta. And Bretta, did you know that you were, as far as the Chinese New Year's go, a horse?
Yes, I did.
You did. You knew that before you came in here.
Yes.
All right, good. Well, you know, I didn't know what my animal was before. But CC is a
Rabbit.
rabbit, and I understand that there are different classifications of rabbit.
Correct.
And you are a
I believe I am a wood rabbit.
wood rabbit. All right. And I found out that I also am a rabbit, but a water rabbit. So I think there were 5, they said, or something like that. So anyway, you can see the different animals that were up there. So the animal of 2025 is the snake. So the snake is thought to bring transformation as it sheds their old skin. So when I saw this and I saw the word transformation, the first thing that came into my mind was geometry. So we're going to take a look right now at one of the things that you can do in mathematics as far as geometry, which is transformations in mathematics. So if we have a figure, there are some different things we can do to it. We can rotate it on an axis. We can have a reflection of that image, like a mirror, a translation, right, which is basically, some people would hear it as a slide, and a dilation where we're keeping it the same shape, but we're altering the size of it. So those are some different transformations in math, and right now we're going to take a look at doing some right now. So this will be our original image that we have is simply a triangle. And you can see that already I did, for the sake of time, we did a rotation on one. So we rotated on the axis and bring it down into the other quadrant so it is the same distance and size. For the slide or the translation, we're now simply going to move this, and let's move it up into this quadrant a little bit more. So we have our original point, which would be down here. We go over 1, 2, 3, 1, 2, 3. We go up 2. Now we're just going to connect those lines, and that is a translation or a slide of the original object, the original drawing or the image. Now the reflection is the mirror image, so we're going to take this and kind of flip it over like that. So we know that we went in 1 on that axis. We're going to do the same thing here. We then once again went over 3, so we go 1, 2, 3, and we are going up 2. We complete that, and we can see that that is a reflection of the original image. So those are some of the different transformations in mathematics and how it all ties together with the Chinese New Year. So Happy New Year, horse, rabbit, and rabbit myself. That is today's Math in the News. We'll be back with more right after this.
All right, everybody, welcome back. Today we're looking at another pattern of mathematics. Today focusing on the relationship between percents, fractions, and whole numbers. Let's see how they interact with each other. So we start out here with 100%. Everybody wants 100%. Usually means you did great, success, outstanding, perfection. But if we take that, percentages are always out of 100. It's a ratio. Okay, so percentage is comparing a number out of 100. Typically, that's our goal, is 100% of something. So if we look at this, 100% is really 100 out of 100. Again, this ratio we see in 5th and 6th grade come up. We're comparing one number to another. It can be written 3 different ways. You can use the word to. You can use a semicolon, or you can also use a fractional bar. So looking at this, we see 100% is the same as 100 over 100. It's also the same as 1 whole, because 100 divided by 100 does equal 1 whole. But now the question becomes, what if it's not 100%? How does it relate? Well, let's think of money. Money is also based on 100 pennies in a dollar, 100 cents in a dollar. How does it relate with 50%? So we have 50%. Remember, our percents are always based out of 100. Again, have a perfect score is 100%, so we're going to put 50 this time over 100. But now how does that relate? It's not the same as 1 whole, because 100 divided by 100 was 1. Now we're doing 50 divided by 100. Well, a couple different ways you can think about it. 50 cents, right? If we go back to our money concept, you have 50% of a dollar, you have 50 cents. How do we make 50 cents? Well, that's 0.50. Don't forget our money symbol. So we see here we have 50 cents, but right now it's the monetary version. What if we didn't want it in money terms? Well, a lot of students might say, well, just eliminate the dollar sign, it has to be right. Well, how do we know that? Well, let's take a look. 50 divided by 100 or 50 over 100, don't forget there is a relationship there. Every fraction is a division problem in hiding. A lot of students, once they begin to understand that, begin to correlate fractions and division much more easily. So 50 divided by 100, let's see here. Well, 100 can't go into 5. It can't go into 50, so now we're into decimal land. We're going to add a 0. 100 goes into 500 5 times. So this quotient is 0.5. But wait a minute, why is this one 0.50? Well, 50 cents, again, we usually don't see 0.5 of a dollar. Other countries, you might see 0.5 of a dollar, 0.5 of their monetary value. But here in the United States, it's typically 50 for 50 cents. Our answer was not 0.5. Well, that's okay. We can add a 0 at the end. And just like that, we see they match. Adding the 0 at the end does not change the value, simply tells us we have nothing in the hundreds place, still worth 50 hundredths by writing it this way. But wait a minute, 50 hundredths, that sounds familiar. Let's see if it matches. 50 in the hundredths place, ending there. 50 hundredths, these match. Well, holy smokes, we must be onto a pattern here. What about 25%? Well, wait a minute, if we can relate to money again, 50 cents was 50 cents out of a dollar. 25 cents, that sounds like a quarter, 25 cents. How many quarters do we need in a dollar? 4. So 25 cents or 1 quarter, hey, there's only 1/4. Wait a minute, these were out of 100, why is this out of a fourth? Again, thinking about quarters, thinking about that relationship, quarters to a whole dollar. 1 quarter is 1/4 because I need 4 quarters to make a whole. If I times by 25, I still get 2,500. So we see the value there that they are the same, it does have the same value. Would it look the same? Let's double check. 25 divided by 100, can't go into 2 or 25. 100 goes into 250 2 times. We'll eliminate some of this work over here, make some room for us. Goes into there 2 times for 200, subtract 50. Can't go in, we drop a 0. And look at that, 100 goes into 500 5 times. 0.25, 25%. Looks like 25 cents. We know. So now we're seeing a pattern between percents, fractions, whole numbers, even money. All of it has to work together. So if you can understand maybe math in money terms, it will benefit you in the fractional side and into the decimals, thinking about money as a decimal, not just as coins you hang around in your pocket or give to somebody. It is a fraction, it is a decimal, they are related. You'll find patterns all over the world in mathematics. What are you going to find next?
Well, that's pretty funny that Mickey said, what are you going to find next? Because that's exactly what we're going to do. He was talking about patterns. In studio, we have Bretta, a 4th grade student from Stockdale Elementary, who you know a lot about patterns too, don't you?
Yes.
All right, so you're going to help me out with a pattern. You can help Cece out with a pattern right now. So I received today, Chinese New Year, the year of the snake. I received this in the mail today at my school. And it's from the fine folks at Innovamat. And on the box, on the package itself, it says which numbers are hidden inside the boxes. So here, Bretta, we can see that we have 2 open boxes and 2 closed boxes, right? So we know 4 and 16 are in 2 of those boxes, but we need to know what's hidden in the other boxes. So I need you and Cece to go over to the board and maybe just put 4 dashes or whatever you like.
We're gonna go ahead and we'll do our boxes.
All right, excellent. So we have an unknown in the first.
So we have, and 4 is here and 16 is here.
Correct. So what I'd like you and Bretta to do is figure out what is going on in the other 2 boxes. Why are those the numbers you're going to come up with? And then let me know when you're through with that part.
Okay.
All right.
So what are you thinking?
Um,
Is there anything that pops in your head like immediately, right away?
maybe 8 right here.
Interesting. Why would you think that?
Because half of 16 is 8, and it's when you add 4 plus 4 equals 8 too. So it's
Okay.
in the middle of them.
Okay, so you're saying if you divided, and then if you divided by 2 again, you'd get to the 4.
Yes.
Okay, so you want to, let's go ahead and we'll do a different color. Go ahead and put an 8 in there. Okay, if that's 8, then what is this?
0.
So tell me again what it was you did from 16 to 8 to 4.
I did half of 16, which is 8.
Okay.
And then I added 4 plus 4, which is also 8. So I thought the answer was 8, but I'm not sure.
Okay, so I'm going to say you did half of 16 is 8. How much of 4 is 8? So I divided by 2.
Yeah.
I would divide by
2.
Okay, and then
Divide by 2.
gives
so
me?
2.
I think that's a really good guess. I think that's a really nice pattern, I think.
That is a beautiful pattern right there. So what I'd like you to do is, if you want to, you can move the 2 and the 8 up and erase inside the boxes,
Okay.
or you can just make some more boxes. Doesn't matter. But I want the 2 and the 8 to stay someplace on the board.
Okay. Doggone it. There we go. Okay, so let's go ahead and put the 2 and the 8 up there, and then we'll see what it is he wants us to do next.
So
All
now
right.
you're not going to put a 2 and 8 in those 2 boxes anymore.
Okay.
But I want you to think of another pattern
Okay.
to complete those 4 boxes.
Interesting.
So see if there's another way you can do this.
I like the pattern you came up before. So this next one is going to be maybe a little bit more complicated. What do we think? What are you thinking? So what's the difference, or how far is it from 4 until 16?
Well, when you multiply 4 times 4 equals 16.
Right. Okay. So I'm gonna. This is my thought on this. Okay. So we did. If we started at the 2, we multiplied by 2 to get to 4. We multiplied by 2 to get here. We multiplied by 2 to get here. Right. Okay. So our multiplication option is kind of done with us, right?
Yes.
Okay. So we may need to do something else. So if we're not talking about addition, or excuse me, multiplication and division, what other operation could we maybe think about?
Addition or
Okay.
subtraction.
Okay, so we know that we're getting bigger, so we're going to have to add, right?
Yes.
So what maybe would we add to get to that middle, to get to the 16? Because it's got to be the same in order to keep it a pattern.
Gotta add from. You have to add.
So I'm going to ask it in a different way. From 4 to 16, how much did we add?
We added
From
so
going from 4 all the way to 16,
Oh.
we add how much?
12.
12. Okay. So if we add 12 going from 4 to 16, what are we going to add here in order to get this middle number? 6. You can say it louder, it's okay.
6.
Okay, so if we add 6 each time, go ahead, and what are we going to get in that middle box? Okay, so does that work? So 4 plus 6 gives me
4 plus 6 gives you 10.
10 plus 6 gives me
16.
Okay, so that's good now, right? So we're
Yes.
okay. So far pattern is working. Okay, what's this number going to be? Do you know?
No.
So now let's go backwards. 16 minus 6 gives us 10. Minus 6 gives us 4. 4 minus 6. Let's think about what we just watched with the money. Do you know what 4 minus 6 is? Let's think about, we can think about it as a number line. We can think about it a lot of ways. But if we're at 4, right, when we subtract, if we're at 4, we subtract 1, 2, 3, 4. How do we keep subtracting 2 more? Do you know? Do you know what's on the other side of the 0? Have you ever heard of negative numbers?
Yeah, negative 1,
Uh-huh.
negative 2.
Okay, so 1, 2, 3, 4. Subtract 5. Subtract 6. What number goes here?
Negative 2.
Negative 2. I like it. What do you think?
Nicely
Mike?
done. So that's another pattern, right? And it's not even a pattern that Innovamat had in their box. You came up with a brand new one. So we're going to take a look at the box and some of the ways that they had right there. And we can see that they had 4 minus 4 is the same as 16 minus 16. That's a pattern, right? They also had the one that you did, 2, 4, 8, 16, right? So you guys were the same on that. They did square numbers. 1 squared, 2 squared, 3 squared, and 4 squared. That's something that you might not have done yet in 4th grade, but you will in 5th and 6th grade, I guarantee you that. And then they had another one. And guess how many different ways there are to do that?
A lot?
How many?
I'm not sure, maybe.
I'm not sure either because there's a lot.
Yeah.
Yes.
Right? There's too many ways that we can count, but there's a lot of ways to do it. But you came up with 2 different ways to complete that pattern. So nicely done for some excellent work so far today. You've got yourself a ticket to go see the Bakersfield Condors, and that season is going on right now. So hopefully you have an opportunity to go see the Condors. You can root them on, maybe wear your Do the Math shirt, and they'll go, hey, look at that kid. That kid was on Do the Math. And you can tell them all about what you did. Sound good?
Yes.
All right. We'll be back with more right after this.
Yes, definitely. But on other worlds, these aren't called earthquakes, they're called moonquakes or Marsquakes if they're on the moon and Mars. We know that these exist because we actually sent seismometers to the moon and to Mars. And when we sent seismometers to these worlds, we actually found thousands of quakes underneath the surface. Even when we don't have seismometers on other planets, we can actually tell that some worlds have earthquakes or had earthquakes in the past because there are cracks of the surface. And so when we see cracked rocks or even cracked ice on places like Europa and Enceladus, we know for a fact that there were quakes there to generate those cracks. Quakes of all sizes are really interesting, and they can tell us a lot about the inside of a planet. Bigger earthquakes, bigger Marsquakes, and bigger moonquakes can tell us about really deep processes and features on these planets. Now, recently, we've discovered that the moon also has a small liquid core surrounding its solid core, and we've also discovered, thanks to NASA InSight, that the Mars core is actually larger than we initially thought, which means it's actually less dense, which is a really interesting science puzzle. So understanding the interior of other worlds will help us understand how our own world, the Earth, evolved. So are there earthquakes on other planets? Definitely. Moonquakes, Marsquakes, and possibly one day we'll be able to send seismometers elsewhere to record Europa quakes and Enceladus quakes and beyond.
And that was some excellent work that Bretta just did, fourth grade student from Stockdale. And we want to thank Innovamat once again for showing us that math is everywhere, even on the packaging that comes in the mail. So you did pretty well with that, I have to say, young lady, finding out some patterns, right?
Yes.
All right. So I know that you're doing some great things in your fourth grade classroom as far as mathematics, but what I'd like you to do is explain to Cece what you're doing in class right now. All right. So head on over to the board, and you're going to help Cece understand what you're doing in class now.
Okay.
All right.
Okay, go ahead and just show me kind of what you got. What are you doing right now?
Okay, so we would have 60 hundredths.
Okay.
And we have 3 tenths. Well, we can't add these because so far what we're learning is we have different denominators and we need the same denominators to add. So we would add a 0 right here and a 0 right here. And we would have 30 plus 60, which equals 90 hundredths.
Very nice. Okay, so, and we're okay just to go ahead and flop some zeros on there and we're fine with it? Do you know why we're able just to go ahead and throw some zeros on there?
I think we have to just throw as much zeros as how much the denominator has.
Right, right. So we know we're trying to get to 100 and we had 10. So you knew you needed another 0, right?
Yes.
Okay. So 10 times what? So if I had this original, I had the 10. I needed to get to 100. So what did I multiply by in order to get that?
You multiplied by 10.
Okay, so when we had the 3 up here, what did I multiply by?
You multiplied by 10 again.
Right, to get me to the 30. Good, because we know that when we want to have fractions that are similar or the same, that are equivalent to each other, or that we need to make sure that we're multiplying by the same thing. So very good, so I like that. All right, so you know how to get that into a decimal and anything else? We want to go that way with it, Mike?
Well, you can do that, or you can give her a different set of fractions where instead of just slapping a 0 on, it's going to satisfy it.
How do you feel about just common denominators in general?
Pretty good.
Okay, so then let's do this. We'll start here. How am I gonna do this problem here?
Well, you would take the 5 and the 10, and you would find all the factors of 5 and 10.
I think you mean multiples.
Multiples,
Good,
yes, multiples.
Good.
So 5, 10, 15.
Do you need to keep going with that one?
20. No, you should have about 4 or 5 until you see like what the least common denominator is,
Right.
that they match up.
So do you already see a common denominator?
Yes,
What is it?
I have 10.
Good. Okay, so what are we going to do now?
I think we would turn the denominators into 10.
Good, I like it. How do I do that? This one's already a 10, so I don't need to do anything there. How do I do this one?
You would add 5 or multiply 2.
Multiply by 2, exactly right. Yeah, we want to make sure we're not adding because that's going to give us, right, okay. So go ahead.
So you would multiply 5 times 2, which equals 10.
Okay.
And then I think you just add these normally.
Ah, but if we multiply by 2 in the denominator,
Oh, you have to multiply that by 2.
fantastic.
2, which equals 4.
Okay, so you want to, let's go ahead and rewrite it then. Let's go ahead and rewrite 4 over 10. And then plus. And our answer is? Fantastic. Okay, I like it. 7/10, right? Okay, so you ready to do one more? We can do one
Well,
more?
before we go on to another one, and
Yeah.
I think we're going to make that the last one, I want to ask you, have you ever done simplest form yet?
Yes, we have.
Is that in simplest form? And if it is, how do you know it is?
Well, I think that's in simplest form because you can't divide anything by 7, like you can't divide 2, 3, or numbers by 7 and 10 because you can't multiply anything to equal 7. So I would think that's the simplest form.
That is simplest
Yeah,
form.
7's a prime number. You're exactly right. So we're done.
Right. So you know the difference between prime and composite numbers.
Yes.
Have you heard those terms before?
Yes, we have.
Good. So if one of the numbers is prime, you know you're done and it's already in simplest form.
Yeah.
So nice explaining, though, of doing that. That was perfectly done. Nicely done right there. 636-4357 is that phone number. We'll be back with more right after this.
Anyone who's ever experienced a major power outage appreciates just how crucial electricity is to our everyday lives. In our homes and cities, electricity even powers the devices in our pockets. That's where electronics and electrical engineers come in. Electronics engineers design and test electronic devices, from portable music players to global positioning systems and computer hardware. They oversee device production and may install and maintain it as well. They test satellites, flight systems, and broadcast equipment. Electrical engineers maintain the power grids that provide power for the country. They also develop and install electrical equipment such as motors, navigation systems, and power generation equipment. Additionally, they ensure vehicle electrical systems operate effectively. The work is intricate and demands great attention to detail and problem-solving ability. They must be able to interpret technical manuals and understand government guidelines. Handling electricity can be dangerous. Although following safety regulations prevent most accidents, these engineers almost always work on teams, so communication skills are essential, especially when talking to people unfamiliar with the field. Electrical and electronic engineers must have a bachelor's degree in the field. The professional engineer license or graduate education can improve a candidate's employment prospects. If you're looking for an empowering career, electrical or electronic engineering just might be a bright idea.
And it is time now for another look at math around the world. And today in studio we have Arabella. Arabella, how are you today?
Good.
And what school do you go to?
Miller Elementary,
Miller Elementary. And what grade are you in?
6th grade.
All right, so you're in 6th grade at Miller Elementary, and you're here to talk to us a little bit about math around the world. What is the culture that you're going to be talking with us about?
I'm going to be talking about the culture of Japan.
All right, and you found out some fascinating things, I'm sure, so let's hear all about it, Arabella.
Okay, so first we have addition, which will, for example, 1, so you're going to add 7 plus 5, which equals 12, and you're going to put the first digit underneath those two numbers, and then you're going to put the next one under the next set of numbers. And then same thing for the next one. So 8 plus 16, 14. You're going to put the 1 under the 2 and then a 4 in that place. And then 2 plus 9, 11. So it's going to, and then you're going to add them all up and it's going to be 1,351. And then next to it, you can see that I put the word math, but in Japanese. And then for example 2, it's 67 plus 14. So it's 6 plus 1, and you'd put a 0 right there, and then a 7. And then 7 plus 4 equals 11, and then you just add them right up, and it'd be 81. And then for the subtraction, so what I've learned is that instead of normal numbers like this, they use in the Japanese Sarab and abacus, right? And then moving on, moving on to multiplication, you have example number 1, 12 plus 14. So what you're going to do is you're going to put one line right here for the 1 and 12, and you're going to put 2 lines right here for the 2 and 12. And then the other way, you're going to put 1 for the 1 and 14, and then a 4 for the 4 and 14. And then so what you're going to do is you're going to find where they intersect. So they intersect right here 1 time. So you're going to put a 1 right here. And then you're going to add these 2 together. So the top, and then you're going to add them together. So 2 plus 4, which equals 6. And then you're going to count every intersection right here, which equals 8. And then you're just going to line it right up, and it's going to be 168. And then for example 2, we have 24 times 14. So you're going to draw 1 line for the 1 and 14, and then 4 lines for the 4 and 14. And then 2 lines this way for the 2 and 24, and then 4 lines this way for the 4 and 24. And then what you're going to do is the exact same thing, just count the intersections. So there's 2 intersections right here, and there's added up all together, there's 12 intersections because there's 8 right here and 4 right here. And then all of this, it looks a lot, but it's actually 16. And then, so what you're going to do is you're going to add the 2 plus the 1 and 12, which equals 3. And then the 2 plus the 1, which equals 3 again. And then you just carry on this little 6. So then it's 336. And then for division, for example, number 1, you have 350 divided by 2. So what you're going to do is draw 2 lines for the dividing number, so which is 2. So you're going to draw 2 lines, and then you're going to put 3 wherever they intersect. So you're going to put 1 right here for the 1, and then 2, and then 3. So then you draw a line, and it's going to be 1 line, so you're going to put 1. And then you have 1 that's odd and doesn't have a pair, right? So you're going to put a 1 in front of that 5 and make it a 15. And then you're going to count this, and then just carry on 1, 2, all the way to 15. Right? And then this is the little odd guy out. So you're going to put a 7, because that's how many lines you have right here, up until right here. And then you're going to put a 1 in front of the 0. And then you're just going to count 10 times. And then that 10 equals up 5 lines. So it'd be 175. And for example 2, you have 246 divided by 2 equals 123. So what you're going to do is draw exactly the same thing, 2 little lines. And then you're going to draw 2 right here, and then that's 1 line. So it'd be 1, and then 4. So then you draw 1, 2, 3, 4, and that equals up 2 lines. And then you have 6, and then you're going to draw 1, 2, 3, 4, 5, 6, and that equals up 3 lines. So it'd be 123. And then I did little drawings to do some of the Japanese culture. So you have some sushi and sushi rolls right here, and then an origami paper crane, and then you have the flag, and then you have math in Japanese, and then you have a little bonsai tree over there, and you have a little like saying hi cat. Okay, and that's my presentation.
Well, nicely done, Arabella. I've got to say that is some excellent work right there, letting us know about this math as far as the Japanese culture goes. And I'd like the camera guy to go back to the addition and looking at that, one of the first problems up there right underneath that bonsai tree. And when you were explaining that, that's beautiful, because I know a lot of students, they start on the other side where you're adding 9 plus 2 is 11. But the method that you're showing us is you're adding the 7 plus 5 is 12 and writing 12 first. And then how you place them is important, and then you're just simply adding up those numbers. And when you started to do that and you were learning about that, do you see an advantage over that or do you like the way that you're doing it, or you do see just two different ways to do it that work great?
I do see certain advantages because it seems so much easier than the regular way we do it. But then again, it's so much easier to just add it instead of doing another pair of addition right here. So I find it more simpler to do it in the regular way we were taught. So I do find some advantages in this, but then again, the way we learned it was, in conclusion, better.
Okay, so I'm glad that you like the way that you've learned it, but I also like how you can see an advantage of doing it that way also. The multiplication is pretty awesome too, the way that you've drawn that out and explained that. It just seems that I think like when you get into really large numbers, you're going to have a lot of lines, and maybe finding those intersections might be a little more difficult, but you've done some great work. And is there anything else? I know that you put some great illustrations on there to show the culture of the Japanese people on there as well. Do you partake, like, do you like sushi? Do you do origami, bonsai trees, any of that kind of stuff that you've put on there?
I did try origami when I was in 2nd grade because my teacher tried to teach us online for school because it was during COVID-19 during that time.
Okay.
So she tried to teach us online, and it was much more harder to learn. And I just got really frustrated, but I've been needing to try it again because, you know, I've grown more, I have more patience than when I last tried it. So I was thinking about trying it again and picking it up as a hobby, but I can't find the time. So then, and then sushi, I did try it once. I do like it, I like it, but I won't eat it like on a daily basis. And then bonsai trees, I only know that from the show Cobra Kai.
Okay. All right, well, good. You know what? You did an excellent presentation right there, and who knows, maybe you'll have another teacher at some point and you can actually in person learn her how to do origami. It'll probably be a little bit easier instead of having to try to do it online, because I know it's pretty difficult learning with online classes like that, correct?
Yes.
All right, well, Arabella, thank you very much for coming in and showing us another one of the cultures as we learn more about math around the world. We'll be back with more right after this.
Welcome to Cal State San Marcos, a powerhouse of higher education with a mission of student success. As a proud federally designated minority-serving institution, HSI and ANAPISI, over half of our students are first-generation trailblazers, and we serve the highest number of military-affiliated students per capita in the entire CSU. As the #1 ranked university in the nation in social mobility, we work with partners to send the message to every young person: yes, you can go to college.
The Alliance program opens doors for students who might not otherwise be on the track for college. Exposure is huge. It provides opportunities for students to see that they can go to college. If they can dream it, they can do it, and see that college is for them.
The most important thing is showing up. And I think they've done that. Making sure that those who need the step further is important. And we have one goal in mind: to make sure we have a successful community for everyone.
Faculty-student mentorship is deepened through undergraduate research, scholarship, and creative activities. As a first-generation undergraduate, Dr. Raymond Malfavon Borja was part of the Center for Training, Research, and Educational Excellence at CSUSM. He went on to get his PhD, and now, in a full-circle moment, he dedicates his time to training and mentoring underrepresented students in the sciences at CSUSM.
It means the world to me to be able to work with our students here, the chance to guide them, mentor them. I take that really seriously. We let them know that we were in similar footsteps to their own, especially myself, right? I was in their seat as an undergrad here, and now I'm on the other side of it, but we share with them that I was first generation, I was a low income student. What's really special is in our center, everyone is first generation. We all happen to be this collection of first generation academic professionals, and I think that's one great strength with connecting with students and helping them to know that if they did it, you know, we can do it too.
Our students learn in and out of the classroom, developing practical skills that set them apart. That includes those who are eager to strike out on their own and make a difference while doing it. Sophia Lombardi is a recent graduate who started her own sustainable swimsuit business as an undergraduate. As a member of the CSUSM Entrepreneurship Society, she won the university's annual Quick Pitch competition to fund her company and bring her vision to life.
The Quick Pitch competition really opened a lot of doors. Specifically, I was able to get introduced to the social enterprise program, which was really cool because both the students participating and myself were able to get real-world experience.
Sophia had the opportunity to lead and collaborate with fellow students, ensuring her business met its demands while maintaining her vision of sustainability.
It's so important for fashion brands to really incorporate sustainability. I decided I wouldn't be a part of that, and I knew it was my responsibility that I had, and I wasn't just going to ignore it.
With a focus on addressing critical workforce needs, our engineering program was established in 2019. Mariposa Rodarte Iman is a first-generation student blazing a trail in a field historically underrepresented in terms of diversity. Our dedicated engineering faculty are empowering students like Mariposa to raise their voices and shine brightly.
It kind of prepares me for the real field that is going to be expected, but to not be afraid and just to only push harder.
Viasat supported the founding of engineering at Cal State San Marcos because we believe in the transformational force STEM fields can have on social mobility. And we're not done yet. We continue to champion and invite community partners to join us in making an investment in Cal State San Marcos and its amazing students. The future integrated science and engineering building will have a transformational impact on our region.
Leading at the intersection of innovation and social justice, Cal State San Marcos magnifies student opportunity, transforming lives and communities.
Being one of the top universities in the nation on social mobility comes with tremendous responsibility. We owe it to our students to double down and make sure that we are serving them and that we get them to the graduation finish line.
Leading with care, fostering academic excellence, and innovating and adapting to the needs of the future. We stand as a beacon of promise and possibility.
That's the power of you. That's the power of us. That's the power of CSUSM.
There we go, another one of the great schools in the CSU system right there. Wonderful work by Arabella on the Math Around the World, and some impressive work so far this afternoon by Bretta, our fourth grade studio guest from Stockdale Elementary. And your shirt, it says Born to Explore, and it says Stockdale Elementary. So explain that to us.
I bought one of these class shirts to represent my class anytime I go somewhere, so I decided to wear it for Do the Math.
Excellent. So I'm glad that you wore that. That way you're representing your class and representing your school. We're going to get into a little something about that later on this afternoon, though, all right?
Okay.
Because I'm going to have another uniform for you. Sound good?
Okay.
All right. So you and Cece head back over to the board. And I know that you were talking a little bit earlier about multiplying fractions. So that's what you and Cece are going to work on right now.
Okay.
Okay, go ahead and talk me through and go ahead and do that problem for me.
Okay, so I think, again, we have to find the common denominators.
We actually only need a common denominator when we're doing addition and subtraction.
Okay,
So we don't need it. This step is obsolete. We don't need it. Go ahead. Multiplication is nice and simple, because what are we going to do?
We're going to multiply the
fractions. Yeah, we're just multiplying the numerator together, and we get?
We get 6.
Uh-huh.
So I'll put the 6 right here.
Yep, and then the denominator, we're going to do the same thing. We're just going to multiply.
Okay, so 5 times 4 equals 20.
Okay, so before the break, we were talking about simplest form. Is this simplest form?
This is not simplest form.
Okay, so what can we do to get it into simplest form?
Now we could find the greatest common factor.
Factors, good. So on this one, we're talking factors.
6
Excellent.
and 20. The factors for 6 are 1, 2, 3, and 6.
Good.
The factors for 20 are 1, 2, 4, and then 5.
Okay. What's going through your head when you pause? You're taking these pauses. What are you doing? What are you doing when you're taking those pauses?
I'm trying to figure out if there's any other numbers, but
that do what? Other numbers
that you can multiply to get 20.
Okay. Okay. Good. So you're at 5. So 6.
6 cannot go into 20.
Okay. So then we're saying, and then we say, okay, what about 7?
7 cannot go into 20.
8.
No.
9.
No.
So we're at 10.
Yes. So.
Okay.
10 and 20.
Okay. And how did you skip so fast from 10 all the way to 20? How did you know that?
10 to 20 because when you get 10 times 2, which we already have our 2, and we said the 10. So when you multiply 2 times 10, we would get 20. And since we already have our 10 and we have 20, so I don't.
No, you're exactly right. So you're doing you're saying what's going to multiply to get me to 20? So 4 times 5 gives me 20.
Yes.
The 2 times the 10 gives me the 20.
And
the 1 times the
20
gives me the 20. Good. Okay, I like it. So what are we going to do now?
Now we have to find the greatest common factor.
Good. Excellent.
From that have to match up.
Excellent.
So it's going to be 2.
Good, because that's the only one that they've got, right?
Yes.
Okay, good. All right, so then we're going to do what with those?
And then we're going to divide them.
Okay. Excellent.
And we will get 3/10.
Nice. Okay, I like it. And we're done because
Yes,
we
we're
did with the greatest, so we're done now. Okay, perfect. I like that.
So, Cece, before you go on to the next problem,
Yep.
we're just going to add a little bonus to this one.
Okay, yes.
So leave everything you've got, maybe get rid of the factors down below, and maybe show her how to cross-simplify first, possibly, and see if that's a method that she might like also.
Okay, have you ever heard of that? That we can actually do some simplification beforehand. So we're going to do this problem again, but we're going to do some simplification before the multiplication. So instead of multiplying and then simplifying, we're going to do this first.
Okay.
Okay, so now I'm going to have you think about it this way. We know that we're multiplying the numerator to the numerator, the denominator to the denominator, right? So we're here.
Yes.
Okay. Is 2 times 3 the same thing as 3 times 2?
Yes.
Okay, so we can flip-flop them, right? Multiplication says it's commutative. We can flip-flop, right?
Yes.
Okay, so I'm gonna kind of go a little bit around the horn for this. Okay. So 3 times 2, 5 times 4. I'm okay with that? I can do that? Okay. Now, if I look at my 3 and my 5, is there any simplification we can do there?
No, because those are both prime numbers.
Excellent. How about my 2 and my 4?
Yes, you can.
What could we do?
You could divide them both by 2.
Okay, so I don't actually need to do any of this. I'm just going to look right back here and I'm going to say, look at my top, look at my bottom. And I see a 2 and I see a 4. So what can I do? You said I can divide by 2s, right?
Yes.
If I take my 2 and I divide it by 2, what do I get?
You get 1.
If I divide 4 by 2, what do I get?
You get 2.
Okay, go ahead and now multiply that through.
So you would get 3, and then 5 times 2, which would equal 10, and you already have it in simplest form.
Exactly right. Isn't that great?
Yes.
I like that.
That's just a little something, a little bonus for you right there, right? So a little shortcut sometimes. Once you get used to what you're doing, there's other ways to do the same problems, right?
Yes.
So go ahead and you guys I think you got time for one more.
Okay, so I'm going to have you do one more thing now that we've done that. And I'm going to give you 2/5 times 4/3 times 10/16.
And I'm going to give you 90 seconds.
Okay, you ready? Okay, we're going to simplify this first. So remember, we're looking at tops and bottoms.
Yes.
So what do we know has some division that works for tops and bottoms?
You could simplify these two, or this
Okay.
fraction, and you would get 1.
Well, go ahead and so you know that they both are 10 and 16 both can be divided by
2.
Perfect. So cross that out, and when we divide it by 2, we get?
When we divide it by 2, we get 5.
Okay, cross that one out, and we get?
8.
Okay, so now again, let's look tops and bottoms. Yes. So what do we see that is that we could divide? Look at here, we've got a 5 and we've got a 5. What can we divide both of those by?
We could divide both of those by 5.
Perfect. So if we cross that out, we get a?
We get a 1.
And that one we get a?
1.
Okay, now look at this. We've got 2s and 4s, and we've got an 8s here. Let's start with this one, maybe.
Okay.
What can we divide by?
You could divide this one by...
Look, we got a 4 up here. Can we divide 8 by 4?
Yes.
So we're going to get?
2.
Okay, and that one is going to get?
2.
Ah, but we divided by, what did we divide by?
Oh, we divided it by 4.
Good.
So we would get 1.
Okay, look it, we got a 2 and a 2.
So we would divide this by 2, and this would be 1. And this would also be 1.
Okay, so now multiply all the way across and tell me what we get.
1. We get 1 thirds.
So isn't that so much easier than multiplying and multiplying and then doing all of this?
Yes.
There you go, nicely done. So come on over here, Brady. You did some excellent work right there. So doing that simplification like you and Cece just did, imagine trying to go 2 times 4 is 8 times 10 is 80, so you can have 80 over some other big number. Then you're gonna have to keep simplifying and keep simplifying and keep simplifying. You never know if you're actually gonna get to the end, but if you do, it's gonna probably take a little while, right?
Especially listing out all of those factors.
Right. So, did you know that you are now an ambassador for Do the Math?
Yes, I did.
Do you know what you have to do as an ambassador?
Solve the Rubik's Cube?
That's one thing. That's part of your duty, but you have to tell other people about Do the Math.
Yeah.
Just like you wore your shirt today to tell us about your class, when you wear your Do the Math shirt, people are going to go, hey, what's going on with that? And you're going to tell them all about Do the Math. Sound good?
Yes.
All right, I'll be right back in a second because we have some exciting stuff coming up tomorrow night. At CSUB, it is Ag Night, and that's going to be presented by Grimway Farms, and that's going on tomorrow night at the CSUB men's basketball game. They had an Ag Night the other night for the women's basketball game, but this one is coming up tomorrow, the 30th, Thursday night, 6:30 is game time. Be at CSUB, celebrate Ag Night with the runners, and hopefully they come out with a win. And I know that in your packet, you've got a certificate for a free Roadrunner game of your choice, so maybe you can go. Did you learn a little something today?
I learned
Quite a bit, I think, right?
Yes,
a lot of stuff.
Yes.
Did you have fun today?
Yes.
That's the most important thing. Are you already a master of the Rubik's Cube?
No.
Well, you know what? You're going to be, because this is an exclusive Do the Math Rubik's Cube. So I'm sure once you try it a couple of times, maybe your sister can mix it up for you. You guys can solve it together. Sound good?
Yes.
All right, good. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.